Welcome back. In this episode, we'll be covering AIRMETs, which stand for Airmen's Meteorological Information. While SIGMETs highlight severe weather, AIRMETs focus on less severe but still significant weather conditions that could affect aviation operations. AIRMETs are crucial for flight safety, especially when flying through areas with moderate turbulence, light icing, or low visibility. AIRMETs are issued for weather conditions that might affect pilots, but they're generally not as extreme as those covered by SIGMETs. However, they still provide important information for flight planning, especially for small aircraft or low-altitude flights. Let's break down the structure of an AIRMET. Similar to SIGMETs, AIRMETs begin with the station identifier, which is the region or airport where the AIRMET is issued. Following this, you'll see the time of issue, followed by the forecast period and details on the weather conditions expected. AIRMETs describe conditions like moderate turbulence, light icing, or restricted visibility that could affect pilots in flight. For example, an AIRMET might look like this: AIRMET Zulu 121700Z 121,803.0015G 20 KT 6 SM OVC 030 ICE. Here's the breakdown. AIRMET Zulu. The type of AIRMET, ZUL, indicates icing conditions. 121700Z. The AIRMET was issued on the 12th, at 5 p.m. Universal Time Coordinated. 121800. The forecast period, starting at 6 p.m. Universal Time Coordinated. 30015G 20 KT, wind from 300 degrees at 15 knots, gusting to 20 knots. 6 SM, visibility is 6 statute miles. OVC 030, overcast clouds at 3,000 feet. Ice, light icing conditions. AIRMETs are essential for flight planning and in-flight decision-making. When pilots receive an AIRMET, they know that certain conditions will be present along their route, allowing them to make necessary adjustments to altitude, flight path, or approach. One of the most common types of AIRMET is the one related to turbulence. AIRMETs will indicate moderate turbulence expected in a particular area. This information is crucial for pilots flying at low altitudes or operating smaller aircraft, which are more sensitive to turbulence than larger commercial jets. For example, if you're flying from Miami to Atlanta, and the AIRMET shows moderate turbulence in the path between the two cities, pilots can adjust their altitude to avoid the rough air. AIRMETs give pilots the opportunity to avoid unnecessary discomfort or, more importantly, dangerous turbulence that might affect the safety of the flight. Another type of AIRMET deals with icing conditions. Icing is a significant concern for pilots, especially when flying in cold temperatures and clouds. AIRMETs provide pilots with information about light to moderate icing that may form on the aircraft surfaces, especially wings and control surfaces. By knowing where icing is expected, pilots can plan to fly above or below these areas to avoid dangerous ice accumulation. AIRMETs also provide information on low visibility conditions. In certain areas, especially in fog or heavy rain, visibility can drop significantly, making it difficult for pilots to navigate or make safe landings. AIRMETs alert pilots to these conditions, so they can either choose to fly at higher altitudes or prepare for instrument approaches in low visibility conditions. For example, if you're flying from New York to Boston, and the AIRMET shows fog and low visibility along the route, you might choose to adjust your flight path or approach strategy. It's essential to have this data early on to ensure that the flight proceeds safely. AIRMETs are also issued for low-level wind shear. Wind shear is a sudden change in wind speed or direction that can be very dangerous for takeoffs and landings. Pilots should pay close attention to AIRMETs that indicate wind shear in specific regions or near airports where wind gusts or directional changes are expected. By adjusting their landing strategy, pilots can minimize the risk posed by wind shear. Let's look at a real-world example. Suppose you're flying across the Midwest, and you receive an AIRMET for moderate turbulence along your route. The AIRMET specifies areas where turbulence is most severe. As a pilot, you can adjust your flight path to avoid these areas or choose a different altitude to minimize the impact of turbulence on your flight. One of the critical aspects of AIRMETs is their role in flight safety. While SIGMETs alert pilots to severe conditions, AIRMETs provide data for moderate weather that can still pose risks. By considering both SIGMETs and AIRMETs, pilots can avoid dangerous conditions while also making operational adjustments to ensure a smooth and efficient flight. It's important to note that AIRMETs are not issued for conditions like light turbulence or isolated showers that don't pose significant risks to flight safety. AIRMETs focus on weather phenomena that can affect pilots' abilities to fly safely, such as cloud cover, ice, turbulence, and wind shear. In summary, AIRMETs are a crucial part of weather forecasting for aviation. They provide information about moderate weather phenomena, helping pilots make informed decisions and adjustments to their flight plans. By monitoring AIRMETs, pilots can ensure that they avoid turbulence, icing, low visibility, and other hazardous conditions. In the next episode, we'll take a closer look at in-flight briefings, which provide pilots with detailed weather information right before and during the flight. We'll discuss how pilots use these briefings to prepare for changes in weather during the flight and adjust their route accordingly. See you in Meteorology number 60, In-Flight Briefing.